Frame relay. Frame relay is a packet switching technology, offered as a telecommunications service by telcos and long-distance carriers, used primarily for WAN links. Frame relay can be used to encapsulate local area network traffic, such as Ethernet frames, for transmission over digital data transmission lines, for wide area networks, and can connect multiple LANs to form a multi-point WAN. Frame relay technology was originally an offshoot of Integrated Services Digital Network digital communication technology. How frame relay work? Frame relay technology is a packet switching service that is similar in operation to, and considered the replacement for, the older X25 packet switching technology, but it provides higher performance, and has a greater efficiency, because it is a more streamlined protocol. For example, while X25 includes error correction functions, frame relay leaves error correction up to the station endpoints, in order to speed up WAN communications. When errors do occur, frame relay drops the offending frame, and retransmits the data. Frame relay also does not support the hop-by-hop flow control functions that X25 supports, which further streamlines frame relay operation. As in other packet switching networks, frame relay operates by breaking network data into packets, and tagging each packet with a destination address. Each packet is then relayed through the switching nodes that make up the packet switching network. The packets are reassembled into the correct order at their destination. Frame relay is a protocol-independent service that uses special frame relay devices for encapsulating network data into variable length packets called frames, using the data link layer protocol called high-level data link control. Frame relay links can have unpredictable latency for forming connections, because frame relay networks have no prioritization scheme. Instead of relaying each packet individually through the frame relay network, frame relay uses virtual circuits that act as temporary paths through the network. These virtual circuits can be either switched virtual circuits that are set up and torn down on a call-by-call basis, or permanent virtual circuits that are established in advance. PVCs are preferred because they provide a more reliable grade of service for the customer. PVCs provide dedicated point-to-point connections between local and remote customer premises through a frame relay cloud. By establishing multiple PVCs, you can run multiple logical WAN links over a single physical frame relay connection. PVCs are managed using the Local Management Interface Protocol, which provides features for verifying link integrity and managing the status of PVCs. PVCs function in a way similar to private lease lines, and provide the customer with a level of service that is agreed upon, called the committed information rate. The committed information rate, a negotiated level of service you purchase from the carrier, specifies your maximum transmission speed over the frame relay network. Speeds typically range from 56 kilobits per second to T3 speeds and higher, depending on your requirements. Committed information rate acts as a kind of bandwidth throttling mechanism that facilitates the use of shared frame relay circuits by different users. Some service providers allow temporary bursts of traffic to exceed the committed information rate, but any traffic above the committed information burst rate is dropped and requires retransmission. Frame relay runs over T1 and fractional T1 carriers, with transmission speeds ranging from 56 kilobits per second to 1.544 megabits per second or higher. Since frame relay is independent of network protocols, such as TCP/IP and IPX/SPX compatible protocol, it has more flexibility than X25. Frame relay implementations usually follow one of two networking topologies. Fully mesh topology. In this implementation, each frame relay device is connected to every other device, using PVCs to form a multi-point WAN. When an update is transmitted to one device, it is seen by every other device as well. The advantage of this configuration is that the entire frame relay network can be treated as a single data link connection. Partially mesh topology. This implementation uses a star or hub and spoke topology, in which frame relay devices are not connected to every other device, in the frame relay cloud. Network designers should be careful when adopting this configuration, to prevent split horizon problems. To connect a network to a telco frame relay bearer service, use a special bridge, router, or CSU/DSU device, called a frame relay access device, or FRAD. The FRAD connects your customer premises to an edge switch on your provider's frame relay cloud, the collection of all frame relay circuits belonging to your provider. Frame relay technology is more popular in North America than slower packet switching technologies, such as X25, while in Europe, X25 has traditionally been a more popular solution. Frame relay services were first offered in 1992 by AT&T, Sprint, and other carriers, which have installed frame relay points of presence for connections to the central office of local telcos in major metropolitan locations around the United States. If you want to learn more about networking concepts and definitions, don't forget to press the subscribe button. To be notified when our channel releases another video, click also on the bell icon. And don't forget to visit our website, networkencyclopedia.com.